Hello guys, now let's continue our course with our next topic, that is linear searching and binary searching. So at the very first, we will discuss about what is searching in data structure. So searching in data structure refers to the process of finding a desired element in a set of items. That is, the set of items to be searched in can be any data structure like list, array, linked list, tree or graph. So let's take one example on it. For example, you search for a specific book in the bookshelf. Like, I want to search for Lee Child. I want this book to be searched out in my bookshelf. So what I will do, I will search it starting from the first book till the end of the bookshelf until I get Lee Child, this book. So I will keep my searching going on until I get this book, this Lee Child. But how? I will check one book one by one. First, I will go to the first book, whether it is a Lee Child, no. So then again, I will turn over to the second book, whether it is a Lee Child, no. So likewise, I will keep my searching going on until I get this Lee Child book. This is how this searching works in data structure. So likewise, in data structure, there are two types of searching methods. The first one is linear search and the next one is the binary search. So we will have a look on them one by one. At the very first, linear search. So what is linear search? A linear search, also known as sequential search. It is a method of finding an element within a list. It checks each element of the list sequentially until a match is found or the whole list has been searched. So let's take one more example. For example, students standing in a line. Right? There are some students which are standing in a line, which are standing linearly or in a sequential manner, you can say. So now I want to find a student with a specific roll number. Let's say there are 1, 2, 3, 4. This one is the 5th student, 6th and 7th. So there are 7 students standing in a line having their roll numbers 1, 2, 3, 4, 5, 6, 7. And now I want to find a student who is having roll number 5. So what I will do, I will check each student one by one, whether that student is having roll number 5 or not until the end is reached. That is until we reach toward this student. So first we will check this student. This is having roll number 1. Is 1 is matching with 5? No. Go to the next. 2. This roll number 2 is matching with 5? No. 3? No. 4? No. 5? Yes. As the specific roll number which we are searching was 5 and this roll number 5 is matching with it. So we found the student which we are trying to find with. So this is how the linear search works. It searches for an element until the end is reached, but it also checks each element one by one and then only it ends. This is the working of linear search. So likewise, linear search works and it checks each element till the end until we find the desired element. We will see program on it. So now we will study about the linear search and we are going to implement this linear search on this array. So first I will tell you that what we are going to do in this program. So here let's assume that we are searching for the element 40 into this array. So for searching 40, we will compare this 40 to each of the element present over in the array and we will try to find it. But before that, we have to store this value 40 into one variable, that is we will store it into key num, and then we will compare this key num with each of the element present over here. If the match is found, then we will simply print a message that element is present in the array. So let's get started here, and at the first we will declare the variables which we need in the program. So in void main, enter int num will be the size of array. The next one is int I will be required for running that loop because we are going to check each element into this array. The next one is key_num. Key_num will be the variable you will be used for storing the variable which we are going to search out in this array. And then found equals to 0. We are initializing one variable found to 0. So later on you will come to know why we are taking this found here. But right now let's concentrate on our program. So in printf, then we are giving the message that enter the size of array, or you can say that enter the number of elements to input. So I am printing the message that enter the size of array. Then I'm going to accept those value through scanf, and I will store that size of array into the num. Now here we go. We have stored the size of array into num. Now we are going to make one array here, that is int array of size num, which user is going to input. Then we will add one more message here that enter the values one by one. So this will be the values which we are going to store in the array. Enter the value one by one. Now, as soon as the user enters this value, we will store it into the array. For storing it, we will require one for loop. So I equals to 0. First initialize I to 0. Then I is less than num until we reaches to the size of array, that is num. So I is less than num, and then increment the I. So this will run our loop, and in loop we are going to accept the values from user, and those values are getting stored in arrays. So how we will write this? And array of I. So here we have accepted those value, and let's assume that we have stored it. Yeah. Now our linear search program begins from here. So next will be the message that in printf enter the value to be searched. Enter the value to be searched. Now after giving this value, we have to store that value which user is going to give us into some variable. So we will store it into the key_num. So in scanf, let's accept that value and we will store it into the key_num. Now key_num will be holding the value which we are going to search for it. Now again we will require one more loop for searching out that value. So for I equals to 0, again the same thing we are going to do. I is less than num, I plus plus. Now this loop is going to run, and we are going to compare that key_num with the elements of the array. If the match is found, then we are going to print the message that element is found. So first let's give the condition if key_num equals to array of I. So what we are going to do now, we are initializing that found, and we are initializing it with 1, and we will simply break our loop here. So why we are doing this? Because you know that at some location, if the match is found, if this key_num is found, so that location also we have to print. But this loop is going to run until we reaches to num, until we search out each and every element until we traverse each and every element. So we need to break this loop explicitly. So if keenum is matched with array, then we will initialize this found variable with 1. Now listen to me very carefully. Now what we are going to do, we are taking one more condition here. Now what we will do, if found equals to 1. What do it simply means? If found equals to 1. When found is 1, when was the found we have initialized 1? When we got keenum, we searched out keenum, we found keenum into that array. So at that time found was 1. So if found equals to 1 means if you got that keenum, if you got the value which you were searching for, then what you will do? You will simply print that value is found. So I am going to print here that element is present in the array. Oh, I broke. And the array at position %d, and my %d would be I plus 1. It's so simple. And what will be my else part will be consist of? My else part will be consist of, if the element is not found, then simply give the message that element is not found. So this is how my code works. This is very simple code to do this linear search over here. Yeah, so we are done with the code. Now we are here on the codeboard.io IDE, and we are going to run the linear search program which we have discussed right now. So here it is showing compilation is successful. So let's run it. So after running it, it is showing me that enter the number of elements. So how much elements do I want to enter in it? Let's say I want to enter 5 elements. Now enter the element one by one. So at the first 12, then 23, 67, 34, 45. Now it is asking me that enter the element to be searched. Now which element I want to search? Let's say I want to search this 34. So I will input 34. So element is present in the array at the position 4. So hey, my element is searched out. It is present at 4th position, and this is how the message is printed. Now let's run it again. I will compile it again and I will run it. Now again I will enter some elements into it. Let's say array size is 4. Oh shit, I have to take here. Yeah. Array size is 4 and 12, 23, 34 and 45. Now there are 12, 23, 34, 45. These are the elements which are present over in my array. Now I will try to search that element which is not present in that array. So I will enter like 78. Now 78 is not present in my array. Let's see what it will print. Simply element is not present in the array. So this is how my program works, and hope you got that how this linear search works. Only the thing you have to do is you have to just first understand the concept of linear search, and then you can easily run out this program. Now let's discuss about the binary search. So what is binary search? Binary search is an efficient algorithm for finding an element from a sorted list of elements. It works by repeatedly dividing in half the portion of the list that could contain the item until you have narrowed down the possible location to just once. So we will take another example for it. As you know that in linear search we have taken example of 7 students which are standing in a line, and you are going to search for a specific one. So as you know that in linear search we have to check for each element to search out the one specific element, and it requires much more time. So hence, to make our program efficient, our searching efficient, binary search, this concept was taken in consideration. So we will take one example where binary search is implemented. Now you have a class of 50 students. Now for searching a specific student in a class of 50 students, it is quite tough, right? Because you have to search for each element to search a specific one. So we will do binary search here. Suppose this is roll number 1 and this is roll number 50. Take in consideration, actually there are not 50 students, but you just assume it. So there are 50 students, and let's say you have to find a roll number 12, a student having roll number 12. So what you will do, you will first find the middle one of this 50 student. Means what is the mid one of students from 1 to 50? So how you will do calculation? 50 divided by 2. 50 divided by 2. 25. Now you want to find the roll number 12, right? Now what you will do, you will compare that 12 with 25, right? Now the students are divided into two parts. The first list will be having roll number from 1 to 24, and the next part will be consisting of the students having roll number 26 to 50. Now you will compare this 12, roll number 12 with 25. So what you will do in comparison, if 12 is less than 25, now you know that 12 is less than 25. So if this roll number is less than 25, you will go to the first list, that is the students consisting of roll number from 1 to 24. So there you will search 12. So for searching, again you will take the mid of students from roll number 1 to 24. That is 24 divided by 2. Actually it is 25 divided by 2. You just take 24 divided by 2. So what is 24 divided by 2? It is 12. So here you got the student which is having roll number 12. This is how the binary search works. You have to go on dividing. You have to first take the mid of the elements, then you have to search for that element. First you have to compare that element for which you are searching with the mid. If it is less, then you have to go to the first part. If it is greater than the mid, then you have to go for the second part. Again you have to do the same things. So these things are getting repeated over the time until you get the specific or desired element. This is how binary search works. This is actually known as divide and conquer. This method which binary search is working on is known as divide and conquer method. Hope you got how binary search works. Now we will see the actual program of binary search. So now we are going to study binary search. So on this array we are going to perform binary search. First of all, I will tell you how the binary search works on this array. So first you have to assume that here is low and here is high. This array is having two parts in it. One is low and one is high. So at the very first, this low will be 0th index position. So low equals to 0. And high will be, what will be high? At the moment, high is 9. So what is the relation between the 9 and the array size? That is 10. So the relation is very simple. If array size is 10 and high is 9, that is 10 minus 1 is 9. So how we will write? If n is the size of array, then n minus 1, what will be n minus 1? N minus 1 will be the high at the moment. Okay. On later on, this values of high and lows goes on changing. So at the moment, high equals to n minus 1 and low equals to 0. So first we have to search out mid. Okay, let's first decide what we have to search. So let us assume that 40 is the value which I am going to search out. So what I will do, I will store this 40 into key. Now this is the key. Key is the element which we are going to search into this array. So 40 will be the key value here. Now first we have to find the mid of this array. So how we will going to find the mid of the array? 0 plus 9 upon 2. Formula for mid is very simple. Mid equals to, you could neglect my dirty handwriting, low plus high upon 2. This is the formula for finding the mid. So here low is 0, high is 9. So 0 plus 9 by 2 is 4.5. So you could round up it and you could take it as like index position 5. So 4.5 will be considered as index position 5. So at 5, my element 60 is present. Now we will compare this mid with the key value. So while comparing, we will see whether the key value is greater than 60 or less than 60. Why? Because here now this array has been split up into two lists. One list is holding the indexes from 0 to 4 and the another list is holding the indexes from 6 to 9. So this is how the binary search works. At the moment, what we are going to do, we are going to compare this mid with this key with mid. Now 40 is less than 60, means we have to do binary search again on this part. Now again, what we are going to do, again between this 0 to 4, we are going to find the mid. So at the moment, low is again 0, but high is going to change because the list has been changed. What is high? So at the moment, high will be high equals to mid minus 1. Right? This 4 is higher at the moment. What is the mid? Mid is 5. So what is the relation between 5 and 4? When we do 5 minus 1, the output is 4. So high equals to mid minus 1. This is high at the moment. But what if the key element which we are going to search is being present in this next list? So at that time, high will be high is at the moment mid minus 1. But if we are going to search that key value here, so high will be mid plus 1, because the relation between 5 and 6 is like 5 plus 1 equals to 6. So here high will be mid plus 1. But right now we are having 40 which is less than 60. So we are going to do operation on this list between 0 to 4. So we will take high as mid minus 1. So what is high here? 4. So 0 plus 4 divided by 2. 4 divided by 2 is 2. So what is present at second index position? It is 30. Right? Now again, the list has been split into two parts. One part is holding the 0 and 1 index position, and the another part is holding only 3, only the third index position. So at the moment, we will again compare this 30 and 40. Now which is greater among 30 and 40? 40 is greater than 30, means we have to do operation on this list, right? But the list is consist of only one index position. So at the moment where the index position is 3, what we are going to do is low is also 3 and high is also 3, right? So 3 plus 3 divided by 2, again doing the same thing. 3 plus 3 is 6, 6 divided by 2 is 3. So what we got? Mid as 3. Now compare the key with the mid. So is key matching with the mid? Right. Key is matching with the mid because in key we have stored 40, 40 equals to 40, and we found our element like this. So this is how the binary search works. So at the moment you got the concept of binary search. Now we are going to implement a program on it. So let me erase this because it is looking too messy. So I will erase this. Yeah. Now let us move towards our program. So in void main, you can take void main, but I will take int main right now. So in int main, again what you are going to do is first declare the variables which are needed further. So int I, low, then what we will need? Yeah, we will need mid, we will need high, n, that is size of array, key to store the elements which we are going to search on. So this is, we are done with this. Now the variables are taken. Let's give our first message to user that enter the number of elements, enter the number of elements. So our first message is ready. Now we will accept that size of array through scanf and we will store it into n, comma and n. So we stored it. Now we have stored it. Now we will declare our array of size n which user has given to us. In the next part we are going to print enter the element one by one. Again the same thing which we have done in the linear search. Now the elements, the user is entering the elements and we are going to accept it through scanf and we are storing it into the array. Yeah, and array. But we will need a loop here because there is not only one element present over here. There are several elements. So for I equals to 0, I is less than n, that is I is less than the size of array I plus plus for incrementing and changing the value, and then through scanf we have accepted it, we stored it. Now in the next part the binary search begins. So let us begin our binary search with giving the first message as like enter the value to be searched, right? So we have given this message. Now we will accept it through scanf, which the value user is going to give us, and we will store it into the key. So and %d and key. So we have stored it into key. Now low equals to 0. At the first low will be 0. And what will be high? Right now I told you high will be the size of array minus 1. So n minus 1. Now mid. How to calculate mid? The formula for mid is simply low plus high divided by 2. So low, yeah, we have to put it in brackets. So low plus high divided by 2. Yeah, divided by 2. Now here mid is going to calculate. Here mid is going to calculate. Then in a while loop we are going to consider the situation. The search is going to continue until we reach the last element of the array. So we have to give that condition into this while loop. So while low is less than high, our searching is going to continue, but until the array of mid is less than key. Now until the element which we are going to search is not found, we are going to search it out. So this only the while condition tells us. Now in if condition, if array of mid is less than key, this is the condition after the array gets split up into the two parts. So if array of mid is less than key, then what we are going to do? we are going to move to this left part, right? So we will write that low equals to mid plus 1, right? So here low equals to mid plus 1. Now in else if part, we will take the next condition that if in else if part we will take that array of mid equals to key, means if the element is found, this is the simple meaning of that line. If array of mid equals to key, then you have to give a message that element is found. Now here element is found, and we are going to print location of element also. So we will simply add at location, element is found at location %d comma mid plus 1, because this is the only location at which the element in the array gets found. So now we have taken our second condition also, but what if the array of mid is greater than key? So that condition also we have to consider here. I will first break it because the loop will continue otherwise. So I have breaked it. Now in else part, again consider the else part. Else high will be mid minus 1. As I told before, high will be the mid minus 1, and again calculate the mid. What will be the mid? Low plus high divided by 2. Now if it happens that element is not present in the array but still we are searching it, so that condition also we have to consider. So we will simply add up here that if low is greater than high, means if whole elements of the array has been searched and now we are at the end of array but still the element is not found, then we will simply print that element is not found in array. So this is how the program works, and hope you got this. At the last written 0. Written 0. Hope you got this program. This is really simple program. Just you need to check up this whole logic over here, and you have to first understand the concept, then only you could write this program easily. So hey guys, thank you so much. I'll see you in the next class.